I'm Dr. Billye Cheek with the Texas Astronomical Society, and I'm here today at the Frontiers of Flight Museum in the Spaceflight Gallery, standing next to the Omniglobe, which is currently showing the surface of the moon. And today my presentation is going to be a tour of the moon, an excursion across the lunar landscape. The modern system of lunar nomenclature was introduced in 1651 by Giovanni Battista Riccioli. Riccioli's map of the moon was drawn by Francesco Maria Grimaldi, who has a crater named for him. When you look at the moon, you'll notice dark regions. These are known as mare, which is Latin for seas. Early observers actually mistook these for bodies of water. But we now know that the distinctive dark coloring is due to the high content of basalt, an igneous rock indicative of volcanic activity. Let's take a look at the prominent mare on the surface of the moon. First, there's Mare Frigoris, the sea of cold, Mare Imbrium, the sea of showers or sea of rain, Oceanus Procellarum, the ocean of storms, Mare Cognitum, the sea that has become known, Mare Humorum, the sea of moisture, Mare Nubium, the sea of clouds, Mare Insularum, the sea of islands, Mare Vaporum, the sea of vapors, Mare Nectaris, the sea of nectar, Mare Fecunditatis, the sea of fertility, Mare Tranquillitatis, the sea of tranquility, Mare Crisium, the sea of crises, and Mare Serenitatis, the sea of serenity. Some of these you may already be familiar with, and others not so much, but that's okay, you can always learn something new. One interesting feature on the moon is called the lunar X. Do you see it in the image to the right? This lunar X is visible from Earth easily in binoculars or with a small telescope. It's created by sunlight falling on the rims of three craters, Lechi, Blanchinus, and Purbach. It's visible only for a few hours before the first quarter moon, slightly below the lunar terminator. Here's Lechi crater, Blanchinus, and Purbach. Do you see it now? There's the lunar X. Other important features are impact craters. The moon is just riddled with craters. The moon has so many more craters compared to the Earth because the Earth has an atmosphere. Wind on the Earth can erode craters, and water can also fill them up. Since the moon does not have an atmosphere, the craters are preserved. The crater shown in this image is Tycho crater. Let's take a look at some well-known craters on the surface of the moon. There's Plato crater, Copernicus, Aristarchus, Kepler. Notice that Kepler and Copernicus have lots of white material as well as Tycho. This is called ejecta. This is moon material that was thrown clear when the impact was created. Grimaldi, there's the creator name for Grimaldi who did Riccioli's map. There's Tycho crater. You can notice that there are lots of lines streaking out from the crater. Those are called ejecta rays. There's Furnarius A, Stevinus A, Lagranus, Lemonnier, Eudoxus, Aristoteles, and Endymion. These are just some of the well-known craters that really stand out, but there are many more as you can see, and many of them do have names. So I encourage you to go look them up and learn more crater names. Another interesting feature on the surface of the moon are called lunar swirls. These can appear in groups or as isolated features. There are three prominent theories of how these lunar swirls are formed. The first theory is that they could be plumes of material ejected from comet impacts. Or they could be fine dust particles from micrometeorite impacts that get sorted by a magnetic field. A third theory is that magnetic field shields the surface from weathering by the solar wind. There have been many landings to the surface of the moon. The Lunar program was launched by the Soviet Union, the Chang'e program by the Chinese, and the Surveyor and Apollo programs by the United States. Of all these lunar landings, only the Apollo program were manned missions to the moon. First, let's look at the Lunar program. The Lunar program was a series of robotic spacecraft missions sent to the moon by the Soviet Union between 1959 and 1976. Let's take a look at some of the highlights of the Lunar program. Luna 9 landed in Oceanus Procellarum. It was the first probe to achieve a lunar soft landing. It was also the first spacecraft to make a landing on any planetary body. It also transmitted the first close-up images of the lunar surface. Luna 16 landed in Mare Fecunditatis, the first robotic probe to land on the moon and return a sample of lunar soil to the Earth, a little bit about over 3.5 ounces. Luna 17 landed in Mare Imbrium. This deployed the first robotic rover onto the surface of the moon, named Lunokhod 1. Luna 20 landed in Mare Fecunditatis, and it obtained lunar samples using an extendable drilling apparatus, and it returned little over 1 ounce of collected lunar samples to Earth. Luna 21 landed in Le Monnier crater, which is on the eastern edge of Mare Serenitatis. This deployed the second Soviet lunar rover, named Lunokhod 2. It returned high-resolution images at different rates, and these were used by the rover drive team to send driving commands to the rover in real time. Luna 24 landed in Mare Crisium. This was the third Soviet mission to return lunar samples to Earth, a little over around 6 ounces, and it remains the most recent lunar sample return mission to date. The Surveyor Program was a series of robotic spacecraft missions sent to the moon by the United States between June 1966 and January 1968. Let's take a look at the highlights of the Surveyor Program. Surveyor 1 landed in Oceanus Procellarum. It was the first soft landing on the moon by the United States. This probe performed engineering tests and transmitted images via its television system. Surveyor 3 also landed in Oceanus Procellarum. It acquired new data on strength, texture, and structure of lunar material. It also imaged an eclipse of the sun by the Earth, and Apollo 12 landed near Surveyor 3 and removed the TV camera and other parts of the spacecraft to return to Earth for analysis. Surveyor 5 landed in Mare Tranquillitatis. This was the first Surveyor mission to obtain information about lunar soil composition using alpha scattering data. Surveyor 6 landed in Sinus Medii, performed a lunar hop to provide data about powered takeoffs from the moon. So this probe actually fired its engines and left the lunar surface for a moment and then landed. And this provided good information about how firing rockets would affect the lunar surface. Surveyor 7 landed near Tycho crater. It acquired more alpha scattering data and took images of the Earth, stars, and the solar corona. The Apollo program were manned missions to the moon that were launched from the United States. The crew of Apollo 11 were Commander Neil Armstrong, Command Module Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin Jr. This mission was from July 16th to the 24th, 1969. The location of their landing was Mare Tranquillitatis, the Sea of Tranquility. The Command Service Module was named Columbia, and the Lunar Module was named Eagle. The crew had a surface EVA time of 2 hours, 31 minutes, 40 seconds, with 1 surface EVA, or extravehicular activity. The crew returned 47.51 pounds of samples made of basalt and breccia. There were 3 new minerals discovered by this mission: armalcolite, which was named for the three astronauts, ARM for Armstrong, ALL for Aldrin, and COL for Collins. Tranquilityite, which was named for the mission landing at the Sea of Tranquility, and peroxferroite. All of these minerals were subsequently found on Earth. The crew also used a seismic experiment package to measure moonquakes, and a retroreflector array, which was used for lunar laser ranging experiments. Here's a picture of Buzz Aldrin next to the Passive Seismic Experiment Package with Eagle in the background. Apollo 12 was the second crewed landing to the Moon and consisted of Commander Charles Pete Conrad, Command Module Pilot Richard Gordon Jr., and Lunar Module Pilot Alan Bean. The location of this landing was Oceanus Procellarum. The Command Service Module was named Yankee Clipper, and the Lunar Module was named Intrepid. This crew had a surface EVA time of 7 hours, 45 minutes, and 18 seconds, with 2 surface EVAs. The crew returned 75.7 pounds of samples and landed about 600 feet from the Surveyor 3 probe, where they removed pieces of the Surveyor spacecraft to be taken back to Earth for analysis. This mission also set up equipment to measure seismicity, solar wind flux, and magnetic field, and relayed the measurements back to Earth. Here you can see Charles Pete Conrad, Apollo 12 commander, examining the unmanned Surveyor 3 spacecraft during the second extravehicular activity, known as EVA-2. The lunar module Intrepid is in the far right background. This picture was taken by astronaut Alan Bean, the lunar module pilot. The Intrepid landed on the Moon's Ocean of Storms, Oceanus Procellarum, only 600 feet from Surveyor 3. The television camera and several other components were taken from Surveyor and brought back to Earth for scientific analysis, and the television camera from Surveyor is now in the Smithsonian Institute in Washington, D.C. Apollo 14 was the third crewed landing to the Moon, lasting from January 31st to February 9, 1971, and consisted of Crew Commander Alan Shepard Jr., Command Module Pilot Stuart Roosa, and Lunar Module Pilot Edgar Mitchell. This location landing was the Fra Mauro Formation, which is northeast of Oceanus Procellarum. The Command Service Module was named Kitty Hawk, and the Lunar Module Antares. The surface EVA time for this mission was 9 hours, 22 minutes, and 31 seconds, with 2 surface EVAs. The mission returned 94.35 pounds of samples, collected the third largest moon rock, Big Bertha, 20 pounds and 4 billion years old. The crew added new seismic studies to the Apollo Lunar Surface Experiments Package and used the Modular Equipment Transporter, or MET, which is a pull cart for carrying equipment and samples. Alan Shepard also brought a 6-iron golf club head and 2 golf balls and took a couple of swings on the lunar surface. Here you can see a lunar surface television image showing Alan Shepard taking a couple of golf swings on the surface of the Moon. And yes, those 2 golf balls are still on the lunar surface. Apollo 15 lasted from July 26th to August 7th, 1971, and consisted of Crew Commander David Scott, Command Module Pilot Alfred Worden, and Lunar Module Pilot James Irwin. This mission landed in the Hadley-Rill Apennine Mountains near Mare Imbrium. The Command Service Module was named Endeavour, and Lunar Module Falcon. The surface EVA time was 19 hours, 7 minutes, and 53 seconds, with 4 surface EVAs. The crew returned 170 pounds of samples and found what was nicknamed the Genesis Rock. It was originally thought that this piece of rock was part of the primordial lunar crust. However, further testing showed that it was younger than the surface of the Moon itself. This mission also saw the first use of the Lunar Roving Vehicle, or LRV. Alfred Worden performed the first spacewalk in deep space during the return trip, and Scott used a hammer and feather to validate Galileo's theory that absent air resistance, objects drop at the same rate due to gravity. Although the mission accomplished its goals, it was marred by negative publicity when it emerged that the crew had carried unauthorized postal covers to the lunar surface, some of which were sold by a West German stamp dealer. The crew were reprimanded for poor judgment and did not fly in space again. Here's an image from Apollo 15 taken by Commander David Scott at the end of EVA-1. Lunar Module pilot Jim Irwin is seen with the lunar roving vehicle, with Mount Hadley in the background. Apollo 16 was the second mission to land in the lunar highlands. This mission lasted from April 16th to April 27th, 1972, and consisted of crew Commander John Young, Command Module pilot Thomas Mattingly II, and Lunar Module pilot Charles Duke Jr. The location of this mission was the plain of Descartes. The Command Service Module was named Casper, and Lunar Module Orion. This mission had a surface EVA time of 20 hours, 14 minutes, and 14 seconds, with 3 surface EVAs. This crew returned 211 pounds of samples. The samples from the Descartes Formation and the Cayley Formation disproved a hypothesis that the formations were volcanic in origin. They also released the Particles and Fields Subsatellite PFS-2, which was released in lunar orbit from the service module. Here's an image of John Young standing in the shadow of Shadow Rock. Shadow Rock stands 9.8 feet high. The astronauts were able to sample permanently shadowed soil on the moon. Apollo 17 was the last crewed landing to the moon, and it was the only Saturn V night launch. This mission lasted from December 7th to December 19th, 1972, and consisted of crew Commander Eugene Cernan, Command Module pilot Ronald Evans, and Lunar Module pilot Harrison Schmitt. Harrison Schmitt was the first geologist to land on the moon. The mission location was the Taurus-Littrow Valley. The Command Service Module was named America, and Lunar Module Challenger. The mission's surface EVA time was 22 hours, 3 minutes, and 57 seconds, with 3 surface EVAs. The crew returned 243.7 pounds of samples. They also carried a biological cosmic ray experiment containing 5 mice, which they nicknamed Fee-Fi, Fo-Fum, and Fooey, 4 male and 1 female. Unfortunately, one of the mice died on the trip, but the remaining 4 mice made it back to Earth. Orange soil was also found by Schmitt at Shorty Crater at the base of the South Massif. This proved to be very small beads of volcanic glass, which was formed over 3.5 billion years ago. Here you can see astronaut Eugene Cernan, mission commander, making a short checkout of the lunar roving vehicle during the early part of the first Apollo 17 EVA at the Taurus-Littrow landing site. This is a view of the stripped-down LRV prior to being loaded up. The equipment that was later loaded onto the LRV included the ground-controlled television assembly, the Lunar Communications Relay Unit, high-gain and low-gain antennas, the aft tool pallet, the lunar tools, and scientific gear. This photograph was taken by geologist Harrison Schmitt, the Lunar Module pilot. The mountain in the right background is the east end of the South Massif. Now let's take a journey to the far side of the moon. Here is an image of the far side by the Apollo 16 astronauts. Some people refer to this as the dark side of the moon. However, this is incorrect. The moon does rotate on its axis, so the far side of the moon is exposed to the sun just like the near side is. However, from Earth, we cannot see this side of the moon because the Earth and moon are what is known as tidally locked. This means that the amount of time that it takes for the moon to rotate on its axis is equal to the amount of time that it takes for the moon to revolve about the Earth. So we only see one side of the moon from the surface of the Earth. The largest impact crater on the far side is at the South Pole in the Aitken Basin. At 1,390 miles in diameter, it is the largest crater on the Moon and the second largest confirmed impact crater in the solar system. Here is a view of the South Pole Aitken Basin from JAXA's Kaguya data. JAXA stands for Japan Aerospace Exploration Agency. Viewed at -45 degrees, the black ring is an old approximation. The elliptical purple and gray rings trace the inner and outer rings of the crater. The color coding in red indicates high elevation, and purple indicates low elevation. Now let's take a look at some highlights from the Chinese lunar program Chang'e. Chang'e 3 was the first spacecraft to soft land on the Moon since the Soviet Luna 24 probe in 1976. Chang'e was named for the Chinese goddess of the Moon. It was launched on December 2, 2013 and landed on the Moon on December 14, 2013 in Mare Imbrium. The Lunar Rover, named Yutu, which is Chinese for Jade Rabbit, was designed to explore an area of 1.2 square miles. And this mission discovered a new type of basaltic rock. In the image displayed here, you can see Chang'e 3, China's first moon lander, which was imaged by the Yutu rover. Here is a February 2014 image of the Chang'e 3 site. The blue arrow indicates the Chang'e 3 lander. The yellow arrow indicates the Yutu rover, and the white arrow is the December location of Yutu. Yutu's tracks can be followed clockwise around the lander to its current location. Chang'e 4 was launched on December 7, 2018 and landed on January 3, 2019 at the South Pole Aitken Basin. This was the first soft landing on the far side of the Moon. This mission deployed a Yutu-2 rover and launched the Queqiao Magpie Bridge communications relay satellite on May 20, 2018. As of May 2019, it had identified what appear to be mantle rocks on the surface of the Moon. Here's an image of the Chang'e 4 landing site. And here is the first panorama from the far side of the Moon.
So I encourage you to get out and go on your own lunar excursion. So here are some helpful resources to get you started. Sky and Telescope's Field Map of the Moon is an excellent, inexpensive resource. You can purchase these from Sky and Telescope or from Amazon. So this is the field map of the Moon. Let me open it up and just briefly show you what it looks like. This is a map of the near side of the Moon. As you can see, there are many craters and they have names. And you can also see the mare that we talked about in this presentation. On the back side, you have a grid system to find craters. So if you know what crater you're looking for, you can find the name of the crater, and then you can find, using the grid on the map, how to find your crater. So you can take some time to discover where things are. And as you can see on mine, this is one that I've actually used for lunar observing. So, sorry, I'm having a little hard time. It's glossy and it folds quite readily. So I'll fold it down just a little bit. You can see I've got lots of stickies here. That's what I used for my lunar program observing. I used one color for binoculars and another color for telescope viewing. So you can do that. You could also write on this with a dry erase marker or a grease pencil, and then you can make marks and then you can erase them because it is glossy, so it's not going to be harmed by dew if you happen to be out on a dewy evening. It's not going to be harmed by moisture, and you can also write on it and erase. The Moon Observer's Guide by Peter Grigo is also an excellent resource. And of course, you can go to Google Moon and you can get immediate help and have fun discovering the moon using Google. If you're interested in observing opportunities and programs, you can participate in the lunar observing programs with the Astro League by going to astroleague.org. They have many other observing programs if astronomy is your interest, and you can find many other programs to participate in. But they have 2 lunar observing programs that are excellent. And if you're interested in getting with a local society, you can contact the Texas Astronomical Society and go to the website at texasastro.org. All my Apollo references are listed.
Thank you very much for joining me on this lunar excursion. I hope you enjoyed it. Thanks very much for watching, and have a great moon day.